Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. Before this short vacation, we have completed with the discussion of textual exercise for chapter number 12, Study of Sound from Physics. Today, we will discuss the additional questions for this chapter. Then we will go through the solved examples and the numerical examples, and towards the end we will solve the activities. Hardly two activities are there in this chapter. So let us first begin with the additional questions. I request all of you to be present with a textbook and a pencil in your hand for marking the additional questions and for the numericals. Let us start with the additional questions. You all know that the textual questions do not cover all the required questions. All the topics, all the concepts are not covered in the form of question answers. So for each chapter, I give you the additional questions which are expected to be written in the notebook. So the first additional question for this chapter is question number A. With the help of a neat labeled diagram, write a short note on sonar technique. Now I will just mark the entire paragraph for you. Every time I need not tell you that you have to write the answers point wise. Now here, when the question is with the help of a neat labeled diagram, then 2 marks are allotted for the diagram over here, wherein I had told you before also, artistic boats and all should not be drawn. You can draw a small ship. The important parts of this diagram here is transmitter, receiver, then showing the transmitted pulse and the reflected pulse, wherein the arrows are very important. When it is the transmitted pulse, it travels towards the bottom of the sea, so the arrow is in the downward direction. The reflected pulse is received by the receiver, so the arrow is in the upward direction. So this labelings are very important. Ship, if you just show a boat in the form of the rectangle, that is enough. Water, show the water. Mark the answer on page number 133 of your textbook. I have marked the entire paragraph for you. How to shorten up the answer and write it point wise depends up to you. Now you are in the 9th standard. Everything will not be given to you. You have to derive from the answers. Sonar is the short form for sound navigation and ranging. You can see on page number 133, you have the heading as sonar. Below it, your first point, this is very important to give the full form of sonar. It is used to determine the direction, distance and speed of an underwater object with the help of ultrasonic sound waves. Need not write this point because towards the end of the answer you will be providing with the use of the technique. You can start your second point from here. Sonar has a transmitter and a receiver which are fitted on ships or boats. Then you have to mention the use of transmitter and receiver. The transmitter produces and transmits ultrasonic sound waves. These waves travel through water, strike underwater objects and get reflected by them. The reflected waves are received by the receiver on the ship. Next point, the receiver converts the ultrasonic sound into electrical signals and these signals are properly interpreted. The time difference between the transmission and reception is noted. This time and the velocity of sound in the water gives the distance from the ship of the object which reflects the waves. I have provided you the answer up to here. Now how to write it point wise? The first point you will write about the full form of sonar. Second point you will write that it consists of a transmitter and receiver installed on a ship or a boat. Third point, you will write the function of transmitter and receiver. Then fourth point, how the difference between transmission and reception is noted. And your last point, sonar is used to determine the depth of the sea and also to search for the underwater hills, valleys, submarines, icebergs, sunken ships, etc. If it is for 5 marks, in short, you have to give the explanation and also you have to provide with the diagram. If only the explanation is asked without the diagram, it can be asked for 3 marks. Only if the diagram is asked, the diagram can be asked for 2 or 3 marks. So according to the question, you have to answer it. Our next additional question is on page number 134 of your textbook. Again, a brief question. Write a short note on sonography technique. Write a short note on sonography technique. Here, no need of diagram in the exam. Page number 134, the very first line. Sonography technology uses ultrasonic sound waves to generate images of internal organs of the human body. Here also I have marked it. Point-wise I have given to you whichever points you want to shorten. You want to skip, you can do it on your own. Next point, continue marking. This is useful in finding out the cause of swelling, infection, pain, etc., the condition of the heart, the state of the heart after a heart attack, as well as the growth of the fetus inside the womb of a pregnant woman are studied using this technique. This point you can surely shorten up the point that sonography technique is used to find out the condition of the heart after or before the heart attack, or to find out the growth of the fetus, or to detect any swelling, infection, etc. This way you can shorten the second point. Continue marking. This technique makes use of a probe and a gel. The gel is used to make proper contact between the skin and the probe so that the full capacity of the ultrasound can be utilized. Next point, continue marking. The gel is applied to the skin outside the internal organ to be studied. High frequency ultrasound is transmitted inside the body with the help of the probe. The sound reflected from the internal organ is again collected by the probe and fed to a computer which generates the images of the internal organ. So I have given you point wise. How to shorten the point, how to write depends on you, how to apply the concept of ultrasound which you have studied in this chapter. Our next brief additional question is very important. With the help of a neat labeled diagram, explain the human ear. Now when they tell you to explain the human ear, then all the 3 parts of the human ear, your outer ear, middle ear, inner ear, all the explanation should be very thorough. During the diagram, if you have watched my previous video very thoroughly, then you will come to know that I have told you all the labelings of the diagram are not compulsory. Which labels you have to do in the exam, once again I will tell you today. So let us begin with the answer. First part, you will just write the human ear can be divided into 3 parts on page number 135. You have the diagram 12.6 of the human ear. Below that you have the paragraph. The second last line of the paragraph is your first point. This is not a point, actually the introduction of the answer. The human ear can be divided into 3 parts: outer ear, middle ear, inner ear. So this part is very important because they have told you explain the human ear. Now every part in short explanation along and one diagram. First is outer ear or pinna. Mark it carefully. The outer ear collects the sound waves and passes them through a tube to a cavity in the middle ear. Its peculiar funnel-like shape helps to collect and pass sounds into the middle ear. Like labelings I will tell you towards the end. Middle ear, there is a thin membrane in the cavity of the middle ear called the eardrum. When a compression in a sound wave reaches the eardrum, the pressure outside it increases and it gets pushed inwards. The opposite happens when a rarefaction reaches there. The pressure outside decreases and the membrane gets pulled outwards. Thus, sound waves cause vibrations of the membrane. Inner ear. The auditory nerve connects the inner ear to the brain. The inner ear has a structure resembling the shell of a snail. It is called the cochlea. The cochlea receives the vibrations coming from the membrane and converts them into electrical signals which are sent to the brain through the nerve. The brain analyzes these signals. Here our explanation is over. Now, in the beginning, I have mentioned the question with the help of a neat labeled diagram. So, when you draw the diagram, all the labels are not necessary. Then, which you have to label, just mark it. Outer ear, pinna, eardrum, middle ear, inner ear, cochlea, and auditory canal. Outer ear or pinna, eardrum, middle ear, inner ear, cochlea and auditory canal. So all other labelings in your notebook also, when you draw the diagram, only this much labels are enough. Because I had told you earlier also, once again I will repeat that maximum weightage of the diagram is 3 marks. So 1 mark for scientifically correct diagram and half mark for each label. So maximum labels here are 4. On the other hand, I have provided you with 6 labels that are more than enough. So all the other labels, this tympanic cavity, chain of 3 bones and all, no need of labeling it. But compulsorily you have to draw the diagram in your notebook. With this, we complete with the brief additional questions. Now 2 or 3 definitions are there additional. Quickly mark it. Our next last additional question is question number D. Define. First definition is velocity of sound wave. A. Velocity of sound wave. For the marking, refer page number 129 in your textbook. Page number 129, you can see the bold black colored font is your definition. The distance covered by a point on the wave in unit time is the velocity of the sound wave. Second, infrasound. Sound waves with frequency smaller than 20 Hz is called infrasound. Now this definition you will get on page number 130. You can see the paragraph of audible, infra and ultrasound. I hope you have got page number 130. The heading is audible, infra and ultrasound. In that paragraph, 7th line you will get. Sound with frequency smaller than 20 Hz is called infrasound. And the third last line of that paragraph is your next additional definition, ultrasound. Sound waves with frequency greater than 20 kilohertz are called ultrasound. I hope all of you have marked the additional questions properly in your textbook. Now, as soon as your textual questions get over, I want this additional questions, definitions, everything written in your notebook. Only you are accepted from writing the solved examples. The solved numerical examples, they are already solved for you in the textbook. So for any chapter, you should not write the numerical examples. You can practice them, but all the other things are compulsory. Now we will revise the solved examples, the solved numerical examples, and then we will start solving the textual numericals. Now these are the solved ones which are already there in front of you. So very quickly we will go through it. The first solved example is, how long will it take, time they have asked, for a sound wave of 25 centimeter wavelength and 1.5 kilohertz frequency of to travel a distance of 1.5 kilometers. How long? What they have given? Frequency is given and they have given the wavelength. Frequency nu is given as 1.5 kilohertz, which we will convert into hertz. So as you know, 1 kilometer is 1000 meter, 1 kg is 1000 grams. So 1 kilohertz is 10 raised to 3 hertz. So when you have to convert into hertz, it will be 1.5 into 10 raised to 3 hertz. Wavelength is given in centimeter, which we will convert into meter. You all know 1 meter is 100 centimeters. So centimeter, if you have to convert into meter, you have to divide by 100. So it comes out to 0.25 meter. Now ahead of you, you have the frequency, you have the wavelength. Let us see what distance is given, 1.5 kilometers. Again this kilometer we have to convert into meter. 1 kilometer is 10 raised to 3, that is 1000 meters. So multiply by 10 raised to 3 meters. Look carefully. Sum is very simple, only you have to take care of the conversions. This kilohertz you will convert into hertz, centimeter wavelength you will convert into meter, and also distance you will convert into meters. How long will it take? So you have to find the time. Velocity formula you have to use as the solution. So velocity of sound is equal to frequency multiplied by wavelength. V, take care, V should be small, is equal to frequency is nu, wavelength is lambda. So V is equal to nu into lambda. So up till here we have seen what is given, what is to be found out, and what solution you are using. Now let us go for the substitution. So V is nu, that is 1.5 into 10 raised to 3 frequency multiplied by wavelength. So wavelength is 0.25. When you do the calculations, you will get as 0.375 into 10 raised to 3. When you multiply 0.25 into 1.5, you will get 0.375 multiplied by 10 raised to 3. That is nothing but 1000. So when you multiply this by 1000, you will get as 375. As it is velocity, unit is meters per second. Now you have to calculate time. So you have to use the solution for time. Time is equal to distance upon velocity. T is equal to distance is S, velocity is small v. So 1.5 multiplied by 10 raised to 3 is the distance. Upon 375 we have got the velocity just now. When you carry out the calculations, you will get the time as 4. As it is time, the unit is second. So the sound wave takes 4 seconds to travel the distance of 1.5 kilometers. So here you have got the answer. They have asked us how long will it take. So you have got the answer. It will take 4 seconds to travel the distance of 1.5 kilometer. Now this is a solved example. So need not write in the notebook. Second solved example we will go through quickly because third solved example they have cancelled. They have removed it out from the syllabus. So let us move towards the next solved example. Example number 2. Ultrasonic waves are transmitted downwards into the sea with the help of a sonar. Ultrasonic waves. The reflected sound is received after 4 seconds. See, the ultrasonic waves, they are transmitted by the transmitter into the sea downward direction, and the reflected sound is received after 4 seconds. What is the depth of the sea at that place, and velocity of sound in sea water they have given as 1550 meters per second. What is given that we will write first. Velocity of sound in water is given. Time for the echo to be heard is 4 seconds. That is your given part. Time taken by the sound waves to reach the bottom of the sea is, see, when you are hearing it after 4 seconds. So to reach it will be divided by 2. So 4 divided by 2, that is 2 seconds. Velocity is equal to distance upon time. Our regular formula. You have to calculate the distance. So velocity multiplied by time. Velocity is 1550 meters per second. Velocity of sound in sea water, time is 2. So 3100 meter. So depth of the sea at that place is 3100 meter. And from this numerical example, what you understand? We have studied about the uses of sonar technique. There they had told that by using the formula, you can get the depth of the sea. You can determine the distance of the, you can say, obstacle from the ship. So by using this formula, the sonar technique is useful in different ways. With this, we complete with the discussion of solved examples. Now we move towards the textual examples. All of you are requested to refer page number 137. Now out of the 5 numerical examples, only the first 3 we are going to solve. 4th and 5th are slightly critical. So the first 3 and this 2 solved examples we are going to do for this chapter. So let us begin with the first solved example. The first numerical example is the speed of sound in air at 0 degree Celsius is 332 meters per second. If it increases at the rate of 0.6 meters per second per degree, what will be the temperature when the velocity has increased to 344 meters per second? So speed of the sound, when the temperature is 0 degrees Celsius, it is 332 meters per second. Now this speed is increasing at the rate of 0.6 meters per second per degree, and they have asked when the speed reaches 344 meters per second, what will be the temperature? It's very simple. You are having 4 chocolates in the first minute. If you are being added with one chocolate every minute, after 10 minutes, what will be the number of chocolates with you? Such simple sum. First, you will write what is given. Initial speed of sound, that is at 0 degrees Celsius. Initial speed is 332 meters per second. Final speed of the sound is 344 meters per second. Rate of increase per degree rise in temperature. Rate of increase of the speed, that is 0.6 meters per second. What you have to find? You have to find temperature when the speed of the sound reaches 344 meters per second. Initial speed is given, final speed is given, rate of increase in speed is given per degree. You have to find the temperature when the speed reaches a particular value. So what formula you are going to use is increase in temperature is increase in speed of sound upon rate of increase per degree rise in temperature. Now if you want to know the increase in speed of sound, you have to subtract the initial speed from the final speed. So initial speed is 344 minus 332. So final speed minus initial speed upon 0.6. This is the rise in speed per degree rise in temperature. So 344 minus 332 comes out to 12 upon 0.6. If you shift this decimal point in the numerator part, it will become 120 divided by 6. So your final answer will be 20 degrees Celsius. So the temperature when the velocity has increased to 344 meters per second, the temperature at that time will be 20 degrees Celsius. Very simple. I have told you, if you are having one chocolate at the first minute, and if every minute one chocolate is getting added, what will be the number of chocolates with you after 10 minutes? So 10 minus 1 divided by increase every minute is 1. So 9 chocolates. So very simple. Now the next one, new textual example number 2. Nita heard the sound of lightning after 4 seconds of seeing it. What was the distance of the lightning from her? You know lightning before a rainfall. So Nita has heard the sound of the lightning after 4 seconds of seeing it. What was the distance of lightning from her? And the information provided to us is velocity of sound in air is 340 meters per second. You have to find the distance. They have asked what was the distance. So very simple, velocity is equal to distance upon time. This formula you have seen how it was applied in solved examples. So same formula, velocity is distance upon time. So V is equal to S upon T. You have to find the distance. So velocity multiplied by time. So S is equal to V multiplied by T. 340 is the velocity. 4 is the timing. So multiply by 4. Answer is 1360 meters. Very simple sum, and the weightage for the sum is 2 marks. They have given us the timing. They have given us the velocity. You are told to find the distance. Very simple. Velocity is distance upon time. Substitute the values. You will get the value of distance. The next textual example is number C. Sunil is standing between 2 parallel walls. The wall closest to him is at a distance of 660 meters. Now this is a person who is standing in between two parallel walls, and the wall which is closest to Sunil is at a distance of 660 meter. If he shouts, he hears the first echo after 4 seconds and another after another 2 seconds. What you have to find? What is the velocity of sound in air and what is the distance between the two parallel walls in which Sunil is standing? Very simple, but you have to apply the logic. What is given? Distance of the closer wall you have taken as S1. Whatever you want to take, you can take it. I have taken small s because distance is s. So S1 is 660 meters. Time of echo from the closer wall is 4 seconds because he hears the first echo after 4 seconds. So the time taken to hear the echo you have to divide by 2. So first time T1 is 4 upon 2, that is 2 seconds, because it will be heard, it is the repetition of sound, original sound. So it is divided by 2. So T1 is equal to 2 seconds. Time of echo from the distant wall. Now this is the closer wall. So time of echo from the distant wall is what? Because he has heard it after another 2 seconds. So 4 plus 2 comes out to 6 seconds. So T2 is 6 upon 2, 3 seconds. You have to find the velocity of sound in air, that is V, and the distance between the two walls, that is the S1 plus S2. Distance from the closer wall and distance from the distant wall, that both distance you have to add. Let us find the first distance by using the formula velocity is equal to distance upon time. S1 is the distance, V1 is velocity, T1 is the time. So V1 is equal to S1 upon T1. You are using the same formula to find both the different distances. So S1 and T1, both the values you have with you. Distance from the closer wall 660, T1 is 2 seconds, you have seen in the previous slide. So 330 meters per second. You know V1 is equal to V2, velocity of sound in air. So V2 you will take as 330 meters per second. Using this value of V2, substitute in the same formula S2 upon T2. V2 is 330. Why it is same? Because speed of sound in air will be same. And what is V1? Your velocity of sound in air. So 330 is equal to S2 upon 3. When you cross multiply, you will get the next distance as 990 meters. So distance between the two walls is what? S1 plus S2. You have the distance from the first wall 660 plus S2 you have found out as 990. Add both 1650 meters. So the velocity of sound in air is 330 meters per second and the distance between the two walls is 1650 meters. Very simple. If you do it stepwise, see everywhere if you see the formula is same. Either you are using velocity is equal to distance upon time or you are using the velocity of sound is frequency into wavelength. So these are the only two formula which you have to remember. So when you start solving the numerical examples or the solved examples, before that you just go through the formula and then you sit for solving the examples, because for writing the given part and the solution you have half mark. So even if you go wrong with the substitution and calculations, at least the formula marks you will get. So I have told you only the first 3 numericals I will be taking and the solved examples. That 3 numericals only you will do in the notebook. Now remaining are the activities for this chapter which we will take up in our next session, and after this immediately I will start with the next chapter for section A, that is chapter number 13, carbon an important element. When both the chapters of section A will get over, then we will start with section B and we will complete both the chapters for section B, which will be the portion for our coming assessment exam. We don't know in which month. So 4 chapters I will keep, 12 and 13 from section A, and let us see what I will keep for section B. So in our next session, I will just request you to sit with the textbook for discussing the activities and go through chapter number 13, that is carbon an important element. At least the first 3 to 4 pages of the chapter you are requested to go through. Till then, Also, I request and I hope that you are completing your notebooks. So, see to it whatever we have discussed today. Tomorrow is Sunday. Immediately complete your notebooks and be prepared for the next chapter. Thank you, dear children.